I'm going to talk about, a little bit following on from that, which is about how we understand how people interact with the environment and with each other, and in the sense that other people are part of the environment. And to try and understand that, we need to understand a bit about how people work. So the yellow line on the right there is today. And that's basically just to sort of mark where we are, because one of the interesting things is we talk a lot about cities. We say half the population of the planet is, or the human population of the planet lives in cities, but actually the kind of cities that we're talking about have only been around for about 200 years. Really since the Industrial Revolution, when we centralized energy and we centralized how we did power, we suddenly had to bring lots of people to the same place in order to work. We did have cities, of course, before that. Some of the first cities were around about 10,000 years ago, where people came together, for example, for access to water. And cities of some sort, or groupings of large numbers of groupings of people, and the settlements of people, around about 10,000 years ago. But actually you have to go back much further to see when we were really changing things. And go back about 40,000 years is when people emerged, well, a few tens of thousands of years before that, the last climate change, when the sort of jungle receded and developed into savannah. And when humans adapted into the savannah, one of the reasons that the human species, as opposed to the other hominids, actually evolved was because we were much, much better at dealing with a really important problem. And that is that we have a big brain. The brain consumes massive amounts of energy. And the only way that you can actually get enough food in order to supply that energy is to cooperate with other people. And so the species that survived out of all that was a social species. We developed language, we developed culture and art and so on. And the interesting thing is, and why I have that timeline, is that genetically we are exactly the same as we were 40,000 years ago. And we haven't really adapted to that. And what that really means is that the savannah is what we're designed for. Big, wide, open spaces, big skies, few vertical stuff, softish ground. And when you think how your foot works, that's what it's designed for. How your eyesight works, it's designed to be able to identify small objects far away and decide whether they're going to eat you or not. Things like that. And what we actually live in is cities. So where you have tall spaces, short horizons, tiny skies, and therefore, simply by being in a city, you're actually in tension with the way in which your body actually functions. And so how do we actually start to handle that? And how do we design the city in order to try and work better with the way that we function is kind of what I think we're about when we're trying to make better places. And a lot of what we've seen already, I think, is sort of gearing towards that. So we started to think about how do we actually understand what's going on. So I thought, this is Roger Federer. Now, interesting photograph of this. I just found it on the web. But essentially, the ball is hitting his racket. And you should think of it that way round, because his eyes are actually looking over here. And his brain is only conscious of the ball at the net 300 milliseconds before. And that processing time is actually the beginnings of how we interact with the environment. We can look at that in a slightly different way. So if you want to do an action, this is from some psychology experiments. They ask people to do an action. Psychologists don't like people to do too much, so they ask them to move their finger. And they say, if I shine a light, you move your finger. Okay? So this is when the finger moves, and about 200 milliseconds before the finger moves, they see a spike in the brain activity, and that is the conscious action of the person deciding to move the finger. Before that, there is another line that is here. This is what we call preconscious readiness. And in order to be consciously aware of the fact of moving the finger, your brain has to prepare first. And what it does is it fires up the brain to be ready to do the conscious piece that is then going to turn into the action. And before that, you have a natural stimulus. So you're talking about that whole process takes a defined amount of time. And really, these are the same for Roger Federer as they are for me. He's just better at tennis. And because the control in there is about the electrochemical processes in the brain. It's about how neurons fire and things like that. It's sort of kind of where we are. That's what we've evolved. Why does that actually get interesting for transport? Well, the first thing we have to figure out is what's actually happening. So if you look at information theory as a basis for this, the brain has a capacity of processing information. Information in bits, binary digits, basically yes or no processes, for those people aware of information theory. And about every second we are processing that at around the rate, or have a capacity to process at around the rate of 10 or 11, just over 11 million bits per second coming in. Of that 11 million bits, 10 million are vision, or vision related. Much less for hearing, interestingly. A bit more for touch, and so on. So this is like the green spike. This is what's coming in. This column is the conscious awareness, the capacity of the brain to deal with stuff consciously. And you can see there's quite a big difference between 10 million bits per second and 40 bits per second. What's going on? Where do those 10 million or 9,999,900, where are they all going? And they used to think that it was sort of, the brain was a really good filter and just chucked this stuff away. But actually that's not what happens. And this is where it becomes important for transport. Because when you walk down the road and you're talking to your friend, you are not aware of what your feet are doing. You're not aware of the feet going over curbs, over uneven pavements, dodging dog poo and all that sort of stuff. Actually, that is all being controlled by your preconscious brain. So that 10 million bits of visual information coming into your brain, so see yourself as a big sort of satellite dish receiving information all the time, it is processing, and so you have to lift your foot up a bit more. You have to do this, you have to go a bit to the left. All of that is going on without you being aware of it, because actually what you're consciously aware of is the conversation you're having with your friend. And that's what you're using your very restricted conscious capacity for. So when we're designing a transport system, we tend to think about the transport system as in the conscious world, but actually we should be thinking of it in the preconscious world. And how do we sort of think about designing that? Now, the brain has a kind of clock. And what the brain basically does is it aggregates pulses in that clock. So when we think about now, it's a very interesting concept. You know, say now it's already passed. So now is a period of time. And one of the things that caught my eye with some of Jan Gale's work was about the rhythm of walking past shop fronts in Copenhagen. We saw it on one of the slides tonight, the 4-second thing. The interesting thing is that is a very typical integration interval for the neuronal clock, where the brain sticks stuff together and says, this is now, is about somewhere between 3 and 5 seconds. And we have a sort of tempo. So walking is actually very good. And one of the reasons that people walking think a lot is that the walking sets up a rhythm. So you're setting up a pulse with your walking. Your brain is actually integrating all that lot together and seeing it in groups of time. We know that that's true because the way we perceive groups of things in time. So why does a clock say tick-tock and not tick-tick? Many languages in the world, every language that I know a few languages, a clock has 2 sounds. But actually the clock only has 1. It's the same sound. Why do we do that? Well, it's because the brain is saying, I've got this thing clicking away here, but one must be more important than the other, so I'm just putting it there. It's put there by the brain. And that is what it's doing when it's walking past the shop fronts in Copenhagen. So it's integrating the time for the shop fronts and measuring it with the footsteps. And that is part of the way in which the brain is simply processing the way it's receiving information about the environment. And that makes it very important how we design shop windows and how we permit footsteps. And that becomes very central to the way in which we design the way we move around the city, particularly if we want to move around the city on our own, on feet. So in our lab, this is a train. It's a very new train, it has no roof. You'll like that. This is London Underground's new idea for a train. It's the air conditioning. This is a mock-up of a new train which is being designed at the moment to roll out in 2020. And what we were doing here was to test how people interact with the train. And so we had about 150 people getting on and off this train, various things, for 3 weeks. They had a great time. And here you can see the platform edge doors. We're seeing what difference platform edge doors makes to all of that. And that's all very important. But actually, each of those interactions is an individual interaction. And depending on when it happens and what's happened just before and what happens just after, that interaction will change. And so with all these people, so this is mimicking, if you like, a peak hour tube operation, we have all these people, we think of them all as passengers, but actually, are they all the same? So how does each of these people see this tube train? Is it something that's the same? Is it something, how do we design for all those people? So we started to think about this, and we brought that into the idea that actually, the world isn't actually built, the world is created in our head. And so what we're sort of thinking is that every one of those people is actually responding to the environmental stimuli in a rather different way. Some people may feel it's too crowded, some people might feel it's not crowded enough, some people might feel they need to move a bit to the left, others to the right, and so on. And so how that actually comes together is actually created inside each person as they go along. That's why walking and going past shop fronts is important, because they are stimulating that process of creativity. So we then have to figure out how do we actually make our transport system work when everybody in that transport system is actually functioning in a slightly different way. Do we try and make them into some cloned automaton type of group crowd speak thing? Or do we find a way of actually enabling them to operate cooperatively in that rather intricate way of different people interacting with each other? That's why that processing of all the brain is important. This is Dave Brubeck. Unfortunately, I hadn't got Dave Brubeck here, but there you go. We could have listened to it. But why is Dave Brubeck here? Well, Dave Brubeck is here because that is exactly what Dave Brubeck is doing. Those guys are creating music every time for the first time. So this is not some piece that was written 25 years ago or 25 years before. And there's some playing it. They are creating, they're responding to each other, they're responding to the audience. How the audience acts will change the way they play. And that's exactly how we all use the transport system. Every time you get on the train, it's different. You never walk down the same street twice. Herodotus is a good model here. So how do we actually get everyone to create that world in a way that actually works together to be able to create a transport world? And I think that is the work of people like highway engineers. So it's not an easy task to do this. And it isn't just to try and find a way of collecting everybody together and do the same thing. This is actually enabling everybody to be their own self, independently at the same time, in a way that enables the city to work. Because if we do that, if we're enabling them to create the world in their own way, then we can actually have a much more creative and social city. Because remember, we are genetically social species. So how we want to do that is to fix how we're going to start asking the city to do things like respond to the challenges, like climate change. Big question about that. We want to get people out of cars and walking, or out of cars into buses, or whatever. We think about autonomous vehicles, for example. How do we actually get them to do that, to meet those kind of challenges? It's what we want them to do, but if we're actually having to deal with 8.5 million people in London, and they're all different, that's a big challenge. So how do we do it? Well, I think the first thing is we have to change the way we think about the problem. So the first thing is, normally we work on this side. So we say, we have a sort of view of the city. This is London. This is Copenhagen, or wherever. Okay, we have an idea, and we think we have a policy for the city. We do things for the city. So we then say, oh, we need to plan something. We then think, well, if we've got a plan, we've got to sort out buildings and engineering and streets and things like that. And then we have, let's make it nice. We'll have some urban design, and we'll make it work a little bit better for people and all the rest of it. And then we start to sort of think, well, maybe we should make it multisensorial. Humans are multisensorial. We process, I work with about 35 senses, different kinds of ways of looking at how we receive information. And that helps us with this. Then we have our brain, Roger Federer and his brain with the ball, having to predict what the ball is doing. And then we have what we think, what we feel. And the normal way that we work about looking at the city is we work downwards to that. And what we're sort of thinking is actually we should do it the other way around. So if I know how people feel, let's get people to feel friendly, feel nice and all that sort of stuff. We know how we can get the brain, we can understand what the brain is doing about that. That tells us which senses are actually more interactive for us, more important in different situations because we're all creating the world anew all the time. That tells us what the urban design should be. And once we've figured out the urban design, we know what to build around it. And then we know what we should be planning. And then we have a view of the city. Let's sort of just turn it around. So normally, when we're talking about transport and traffic and stuff, we're sort of in this box. We're in that kind of box. So we're sort of looking at the engineering, the architecture and stuff like that. When we spend an awful lot of time teaching people, as you were saying earlier, not to look too far outside the box because there lie dragons. And one of the dragons is neuroscience. And actually, when you get into here, you have to start looking at how the brain works. And it's really fascinating working with neuroscientists to understand how people go over the much lower step in the circle line with the new trains compared with the old trains is a neuroscience problem, not an engineering problem. And we have to understand that. And then we can start thinking how we put it back together. So if I understand how the brain works, I can start to understand how the transport works. And if I know how the transport works, I know how I'm going to start doing my planning. And if I know how the planning works, I can start looking at my city a bit more. And that way we can start to do that. But we can only really do it by understanding the interaction between people and the environment at that very, very detailed level. And that's kind of what we do. And the key to all that is actually the people in the middle. Because in a sense, the person with that 2 kilos of rather powerful computer sitting on their shoulders is one of the best instruments we have for measuring what's actually going on. We just don't really know how to record the measurement as well as we should. And that's a really, really important point. So putting people in the middle is really, really important. And this is some photographs from my lab, but I just wanted to point out too, this one is an experiment we were doing to test how the deep hippocampus, the sort of reptilian brain, navigates. This is not, so you can't navigate in that experiment by thinking, I'm going to go left or right, or I'm going to go past the blue thing, whatever. This is simply using your deep brain that remembers paths simply because of where you are. This is work we've been doing with, that was with some blind people looking for work for London Underground on the humps for the London Underground platforms, where they were trying to make them more accessible, and we were trying to figure out whether that would be upsetting for visually impaired people to suddenly find the platform which they thought would be flat, and suddenly it doesn't. Things like that. And we also have, on the bottom right there, we have work we're doing with people with dementia to understand how people with dementia see, so that we can actually enable people with dementia to be able to live in the city like everybody else. And some work we're doing there in Japan. And the idea is really by understanding this kind of way in which people and that environment interact, including how they interact with other people, put that all together, and then we can understand how we can actually make a better city.